In this video, I will talk about what MATLAB can be used for, the basic skills needed to navigate around the program, how to calculate simple equations, and how to plot graphs. MATLAB stands for Matrix Laboratory. It's a programming language developed by MathWorks. You can use MATLAB to deal with matrices and arrays, to plot 2- or 3-dimensional graphs, to solve algebraic equations, nonlinear equations, for statistics, data analysis, integration, differential equations, numerical methods, curve fitting, and many other special functions. MATLAB has its own development environment, which you are currently viewing. On the left, there is the current folder window. This panel allows access to project folders. On the right, there is the workspace. This shows the variables either created or imported. Let's begin with a demonstration. From the command window here, I can do simple operations. For the purpose of this video, I will define a new variable a and set it to 5. I will define another variable b as 20. Notice that now there are 2 new variables seen in the workspace. I can add them together and get the answer as 25. Similarly, I can do a minus b and get the new answer as minus 15. Notice that the variable answer has changed. To clear the variables, I can type in clear and the variables will be cleared. To clear the command window, simply type in CLC. If you want to execute a series of commands, typing them in the command window won't be possible. Instead, they can be written into program files with .m extensions. As with our previous example, I can set a to 5, b to 20, define a new variable, sum, as a plus b, and display the result. I need to save this file in order to run it. Let's call this file apple.m. Now I can either use the run button or do this. The semicolon indicates end of statement. You won't get an error if you don't use them. However, they suppress the output from appearing in the command window. So when I remove the semicolons, I will get a, b, and sum displayed separately. I recommend using semicolons, especially if you have longer codes. You can also add comments in order to make your code easier to understand. Otherwise, your future self and other people might have trouble understanding the variables or equations. These comments will be ignored by the compiler and they are just for the reader. Now let's begin with a for loop. A loop structure allows us to execute a group of statements multiple times without the need for writing the statement more than once. Before we continue with the for loop, I want to explain what this line is for. All variables in MATLAB are stored in multidimensional arrays. A matrix, for example, is a 2-dimensional array. This line here creates a variable r whose values are stored in a row vector. The colon operator lets me define a row vector starting from 1, ending at 6, with increments of 0.1. The colon is very useful when you want to create arrays as such, and then iterate over the data. Now I will clear the command window for a clean start. Since R is an array, its elements can be represented by indices. For example, its first element is 1, its second element is 1.1, and so on. This for loop will iterate over R. It will take the inverse square of each element of R and then multiply it by a constant. The values calculated will be stored in another array called int, which will be the same size as R. The variable I is defined within the for loop. It It's used for indexing purposes. The for loop executes starting from I equals to 1, ending when I equals the size of array. At each iteration, the value stored in I increases by 1. At the end of the iteration, I will have its final value, which is the size of R. Now let's run this code. Keep an eye on the workspace. See that now I have two more variables, one for I and another one that I calculated for. Now that we've successfully executed this part of our code, we can continue with plotting graphs. To see R versus int on a graph, I can use the plot function. To name the x and y axes, simply use x label and y label as such. You can similarly add a title to your graph. Now if I wanted to add another graph to the same plot, I can use the hold function. I will define a new variable int2. It's almost the same as int, but doubled. Hold command holds the current graph in the output figure. Therefore, when I use plot function again, it draws on the same figure. Since now I expect to have different curves in the graph, I should also put a legend. Matlab has many features, therefore it's important to be able to navigate around the documentation. The documentation is very helpful when you're confused with the syntax or searching for a function that might be built in the language. For example, let's take a look at the graphics. Let's have a look at line plots. Functions related to line plots are listed. You can reach information about the functions, the syntax, the arguments, etc. You can also see some examples. Similarly, let's have a look at matrices and arrays. Matrices and arrays are the core of MATLAB and you should get used to them. I hope this was helpful and thank you for watching.